Hello once again. We've got our claims, we've got our hypotheses, we've got our test statistics. Now it's time for us to get some p-values. Let's answer the question, what do we do with the test statistic now that we've got it? And to answer that question broadly is kind of difficult, but to answer that question specifically for the test statistic that is a z-score, that is easy to answer because all we've got to do if we've got a z-score, a test statistic, is, surprise, surprise, pull up a z-table. That'll get you there. You can calculate your p-values, assuming you have this test statistic, with just a z-table. And I'll show you that here in a second. But what you do with your z-table depends on what kind of hypothesis you're testing. Right? If your hypothesis, the alternate one, right, was that you were less than a specific value, then you want just the left-hand region. And to do that, you just get the value of the z-table. Hey, that's not so bad. And if you want the right-hand region, that's also not so bad. Of course, the z-table will only get you the left-hand region, so you get the complement of that, right? You subtract it out of 1, and that'll get you a right-hand region. So that's your left tail and your right tail test based on if your alternate hypothesis is less than or greater than. And finally, if you have this non-equal alternate hypothesis, you go twin-tailed, you go doublies. And what you find is twice the value that you got off the z-table, or whatever the smaller value is anyway, right? So if you're over here, you'll want this a little bit, and then you'll double it. And if you're over here, you'll get this little bit, and you'll double that. But anyway, so let's return to the question, what do we do? Well, I've got some test statistics, so let me pull up my table, and let's see here. For this first one, we had the alternate hypothesis of p greater than 0.2, so I want that right-hand region, and my test statistic was z equal to 1.095. Of course, most z-tables only go to the nearest hundredth, so we'll go to 1.1. And that gives me a value off of my z-table of 0.8643. But since I want what's above my z-score, I want the right tail, I will get the complement of that. So I'm looking at 1 minus 0.863, which is about 1.367. For this next one, I can do another lookup. Let's see here. I had a z-value of negative 2.63. So negative 2.63 gives me 0.0043. I gave you an extra decimal place there. But based on this z-value, since we want less than 0.85, 85%, we get this as our p-value. No complements needed, right? Because it's strictly less than. Finally, for this last one, we would have our work cut out for us, but if you look at this z-score, it's so huge, right? Most z-tables only go out to 3 standard deviations. We're looking at 5, 5.5. This just is nothing. There is nothing for you out here. So even if you double nothing, you still got nothing. That's why I'm calling this p-value 0 plus. And that's how you get p-values. You find the regions that you need, and the regions you need depend on your hypothesis. And once you've got your regions, once you've got your p-values, what do you do with it? What do you do with it? And what you do with it is you compare your p-value to alpha. And remember, alpha is the significance level. And you have to decide this before you get p-values. Because you got to decide in advance before you give yourself confirmation bias or any kind of testing bias. Decide in advance what alpha is. I've said secretly that alpha needs to be 0.05 on all of these slides. So I am comparing all of my p-values to 0.05. And if p-values are less than that alpha value, one thing happens. And if p-value is greater than alpha, something else happens. So I want you guys to read over this and decide, based on these test statistics and p-values, what we should do next. I'll see you in the next video.